Example 3. Let theta be an acute angle such that sine of theta equals 5/6. Find all the other trig functions of theta. What do you think we should do?
Draw a triangle.
Draw a triangle.
Basically, one of the things that will help you survive trig while you're drawing the triangle. One of the things that's going to help you survive trig is drawing out exactly what you are told. So if they give you a triangle of some sort, stink and draw that sucker out and get a good eyeball on it. It's just crazy important to do that.
Okay, so we don't know what theta is, but that's okay. The
all right.
opposite side is 5.
The hypotenuse
is 6.
Yep.
I decided to draw it in like the first quadrant because we had that on the first slide, and I think that's going to help later on when we start putting angles in other quadrants.
That's pretty good.
So
pretty good.
that's why I did that as opposed to what we've been doing. I think that we need to find the adjacent side because as soon as we try to find cosine, we're going to need it.
And it says to find all the other trig functions, which means that we are going to have to find cosine.
So we do the Pythagorean theorem, which since we know the hypotenuse and a leg, we subtract them. 6 squared minus 5 squared underneath our square root. If you do this on the calculator, take just the part under the square root. 36 minus 25, which is 11.
Right.
And then you write the square root over it. Simplify
you cannot
Don't
put
tell
this
us
into decimal.
3 point blah, blah, blah.
Right. That's a big old
wrong. Yeah.
So,
don't do it. It's square root of 11. Yeah. Because that is an exact value.
Exactamundo.
Okay, if you were to put the decimal, you've rounded, and that makes that approximate.
Yeah.
So square root of 11.
Don't build my bridge if you're going to round.
Yes, because then the bridge might fall down because of a rounding error. Yeah, totally. That would suck. Square root of 11 over 6. Have you ever? There's this video of this really super wobbly bridge, like from way back in the day.
I've seen it.
I bet that was a rounding error.
That was what happened.
Yeah. Yeah, it was.
Hey, it got out of phase, which has to do with trig functions.
Yeah. Yeah.
We're going to have to show that video later.
Yeah, we will.
Okay.
So I was just going through my little identities, adjacent over hypotenuse, opposite over adjacent. Oh, I guess we could rationalize this and make this 5 square roots of 11. Over 11. Over 11. Yeah. That's an 11 underneath that square root.
That's good. Now it's a big blob. It was an 11. Now it isn't. It's, wow. It's like it just undid itself magically.
Okay. And then we need, don't forget, cosecant.
Secant and cotangent.
Yeah. Cosecant is the opposite of sine, which they told us initially was 5 over 6. So that's 6 over 5. Secant is 6 over the square root of 11, which is rationalized 6 square roots of 11 over 11. Cotangent.
Square root 11 over 5.
Square root 11
Go
over
with
5.
that first guy first.
Yeah.
Makes life just...
This one, not this one.
Yeah, right.
All right, so that's all we had to do there. So it mattered what the sides were. We had to find the third side. If we needed to simplify, it's good to practice simplifying, right? Right? So like if you get the square root of 40, well, that's not the way we want to leave that.
No, don't leave it that way.
Remember, you talk about splitting it up into a perfect square and whatever's left over. So
4 and 10.
4 and 10. You can take the square root of 4.
But not the square root of 10.
But not the square root of 10. So you put the 2 on the outside for the square root of 4. And inside, you leave the 10. This was a completely random made-up example. Please don't think that this has anything to do with the rest of what's on the slide.
No, it doesn't. Nothing at all.
Nothing
In fact,
at all.
while Ms. Stevenson starts the next one, I'm going to grab a calculator.
Okay, a right triangle with a hypotenuse of 8 includes a 37-degree angle. Find the measure of the other two angles and the length of the other two sides. So,
make sure your calculator's in degree mode.
I was just about to mention that.
Just be in degree mode.
It really doesn't matter which angle we label as 37 degrees, just that we label one. A right angle with a hypotenuse of 8. It wants us to find the measures of the other two angles and the lengths of the other two sides. Well, hey, look, that one's a right angle, so that one's 90 degrees. And hey, there's this thing where triangles, angles have to add up to be 180 degrees.
Shut the front door, 53.
So that does make that 53 because either you could do 37 plus 90 and subtract from 180, or you could say, well, I already know this is 90. These two have to add up to be 90. So then you could just say 90 minus 37.
Right.
So this is an answer. This is an answer. Now we need to figure out what these two sides right here are. And we use trig functions to do that.
Yeah.
Like
I would have probably labeled it X on the bottom and Y on the other side because X usually runs left, right, Y usually runs up and down. Just me.
Okay. Now
there you
they're
go.
labeled.
Perfect. Okay.
Okay, so down here at the bottom,
That's
let's find
exactly
x.
how I would have done it.
This is the adjacent side. We know the hypotenuse, so we need to use cosine of 37 degrees. Might as well use the angle they gave you in case you randomly screw up and subtract.
Always use the angle they give you.
Yeah.
Always.
Always. X over 8, adjacent over hypotenuse. How do we solve this? There's like a cross multiplying kind of situation going on, or just think of it like you're timesing 8 on both sides. Whichever way makes you feel more comfortable. That's what's going on. So 8 times cosine of 37 degrees. And like Mr. Hazelwood mentioned,
6.389. You'll need a calculator.
389.
Now, if you don't,
I was meaning make sure it's in degree mode.
Oh yeah, make sure it's.
How do we know that it's supposed to be in degree mode?
Because it says 37 degrees right there.
So if it says degrees, we put it in degree mode.
Oh yeah.
And if it doesn't say degrees, we need it in radian mode.
Yes.
That sounds so simple when you say it like that. Hint, hint, wink, wink, nudge, nudge. Like, come on, guys. Degree mode is degree mode, and radian.
Yeah.
Okay.
And if you get now, when you're doing this, a real easy check is sometimes if you're not in the correct mode, when you know you should get like a positive, small positive answer, you could get some real wacky, weird negative number. And,
or like some decimals that shouldn't. Why did I just write cosine? That's going to be sine.
Danger, Will Robinson. Danger.
I've seen that movie one time. What's it called? It's like from the 80s.
Robinsons.
90s.
Family Robinson Crusoe.
No, that's not it.
Oh.
What? It's some space movie. So times by
Lost
8
in
on both
Space.
sides. There we go. Times by 8 on both sides. Now, if we didn't know the hypotenuse, we would have to do some fancier algebra here. 8 times sine of 37?
4.814. And there's no need, you can go to the third decimal place. You can either round at the third or truncate, which means cut off. So it just depends on
4.814 or 4.815.
Yep.
Either one of those answers would be correct.
It's a good answer.
Okay, just make sure you round to 3 decimal places. The more decimals, the merrier. Anything?
Well, no, there's 3 decimal places, period.
All the time.
Yeah, every time.
Yeah.
Yeah, not the more the merrier.
No, not the 3. 3 is the perfect number.
Symbiotic.
3 is not a crowd. It's the perfect
It's a symbiotic relationship.
number.
Yep, it's perfect.